Welcome to Enviro Quant's Tune Evaluation. In the environmental analysis flavor, you have a choice of launching the Tune Evaluation application. The Tune Evaluation application offers two broad capabilities. One is to evaluate a tune compound, and that could be BFB or DFTPP or even your own, and it provides chromatography evaluation capabilities such as evaluating tailing. Let's step into how this works in tune evaluation. You have a method. You can edit that method. You can load that method, save the method. So for the tune evaluation, you have the ability to define criteria that it must meet in order to pass by picking an ion and then some ratios associated with a related ion. You can also pick an alternative base ion to get those percentages. And over here, you have the ability to invoke an auto settings, which tries several spectral extractions. The auto settings will try all of these in combination to look for a passing criteria. If you want to override that, you can do the manual spectral evaluation, and that you get to choose from these three in terms of where in the peak you're going to pull that particular spectrum and how you're going to deal with it in terms of subtracting the background, either from the front, rear, higher of the two ends, or best scan within. You can dictate that manually. For the demo, I've started up Tune Evaluation from the EnviroQuant Tools menu. For the demo, I'm going to manually load a data file. I'll pick this one, DFTPP, and then I will manually load a method. And you'll notice the criteria here, and I'll apply that, and you'll see that all the criteria are met. Now let me point out that in the shipping you can just use preset BFB or DFTPP settings, and I used my own. Let's look at the other capability of this application, which is evaluating signals and their breakdown and tailing. It can be done for GC. I will show you that capability with mass spec signals. So here is DDT, and I'm going to look at the breakdown products. So first I'm going to define the signals with its retention time and quantum qualifier ions, so I can find those signals. And I'm going to take this DDT as the parent signal and evaluate breakdown characteristics of DDD and DDE in terms of the heat of the injection port. In a similar manner, I'm able to evaluate the tailing factor for pentachlorophenol and benzodiene. And if I look here, I define those signal types in terms of the ions that I'm looking for and the tailing factor limit that I consider to be acceptable. So the demo, basically looking at the GC performance evaluation criteria that I have just gone over, applying those, and you can see that on the chromatogram evaluation results, I've got a pass for the DDT breakdown, and pentachlorophenol and benzodiene are within the limits of the tailing factor as calculated. Let's do a quick visual confirmation of benzodiene here at 6.3. If I go to 6.3 and look at that part of the chromatogram, I can see there is some tailing, and I can look across the peak and check out 184, which is my target ion for benzodiene. And last, I can capture that information in a report from the report menu. I can generate a PDF file, and that will turn into a nice capturing of what you see on the screen with the criteria and the results, as well as the details of the chromatographic evaluation. A quick demo of the Tune Evaluation report. Here I'm going to put it in that set of data files, Tune Evaluation report. And here I've got a very nice depiction of the Tune Evaluation report with the criteria and that it passed. And I can see all the details of the signals and the breakdown that we just discussed in terms of its passing with the breakdown as well as the tailing factor. Thanks for your attention.